In this video, we'll be building on some things that we've already done. This is a great example of how we learned some, I would call them foundational tools and strategies, one of which is the order of operations. Whenever I introduce the order of operations, I always describe it as the rules of the road, right? If you're out driving a car, for example, everybody had better respond to stop signs the same way, right? Yellow lights versus red lights, green lights. If anybody doesn't follow the rule of the road, the outcome is not going to be ideal, most likely. So that's the same thing with order of operations. It's really the rule of the mathematical road. So it doesn't matter whether you're dealing with fractions, integers, decimals, imaginary numbers, which, don't worry, we won't be talking about imaginary numbers, but it just means throughout math, you are always using that. So here we are going to be using order of operations, like always, for simplifying each side of the equal sign. And then we will follow the process for solving, right? Which at that point is combining like terms across the equal sign and then doing reverse operations to cancel everything. Okay, so I wanted to leave the calculator up here for a minute because notice we are dealing with some negatives. And I wanted to make sure that you were comfortable with how to enter negatives into the calculator. Because if you look at the calculator here, there are two negatives, right? There's this, which actually is subtraction. And then right here, this one is the negative in front of a number. So when you're entering any negatives, you have to make sure to use this. Okay, so we'll do that on B and probably C to illustrate that. And then I'm going to go ahead and close the calculator, most likely, or not. I don't know. We'll see. Okay, so here I look at A, and I see that I don't have anything that I need to combine on each side, right? Because step one for solving is to simplify on each side. So now that that's done, I need to get x by itself, and I do that by eliminating what's next to the variable, and I do it using the opposite function. Now with addition and subtraction, 2.4, 2 and 4/10 is a positive number. So in order to cancel that, I need it to end up equaling 0. The only way to do that is to subtract by 2.4, or again, 2 and 4/10. Okay, so I get x, then minus 2 and 4/10 equals. So I'll go, might as well. This is kind of cool. This may be my new thing, to just have the calculator on the screen. Why not? Okay, so here, right, I have minus 2.4. I hit enter, and there you go. We have 2 and 85 hundredths. Now the instructions here did not specify where to round. This one, 2 and 85 hundredths, is a terminating decimal. The value of terminating decimals is that they are exact answers. You didn't have to round anything. So I usually suggest rounding to the 10th place if it isn't indicated somewhere where you need to round. But if it's a terminating decimal, go ahead and just write the whole decimal down. If it's like, 8 places to the right of the decimal, don't worry about it. Cut it shorter, maybe like the 1,000th or something, but we want to keep all of those places to maintain an exact answer whenever we can. Okay, so this time, looking at B, I notice that the left-hand side are not like terms, so I can't do anything. But over here, I do have like terms. I have negative 3 and 4/10 plus 12 and 1/10. Okay, so this is a good example of how I use the negative sign instead of the subtraction sign when I'm entering this into my calculator. So I get negative 13 and 4/10 plus 12 and 1/10, and I get negative 1.3. So negative 1 and 3/10. So negative 1 and 2/10 minus x. Okay, now I'm actually going to show you something, because another confusing thing that can come up is the difference between plus a negative and subtraction. So notice the first time that I entered this, I did negative 13.4 plus 12.1. So the commutative property of addition says that I can actually flip that and I will get the same answer. So I am going to do 12 and 1/10, but instead of doing plus a negative, I'm going to write that as subtract 13 and 4/10 and see what we get. Look at that. So if I were to write that as plus a negative, which I'll show you how to do that. Also, these guys equal exactly the same thing. So I'm going to rewrite this, but this time it's going to be 12 and 1/10 plus, and then because I'm doing a negative, it's negative 13 and 4/10. And look at that. It's the same answer. Now, I bring that up because when there's a negative, right, that negative always goes to the number next to it. So in this one, it said subtraction, right? And it gave us negative 1 and 3/10. Here, it's written as plus a negative, and you get the same thing. So it's a great demonstration of how the sign in front of the number goes with the number. Okay, so keep that in mind as we work through these. All right, so I don't have anything on one side of the equal sign to combine. So I'm now ready to start moving across the equal sign. Okay, now when I talk about solving, when I first introduce it, I talk about GEMDOS, right? G for grouping. And I draw a little chart here and I show, okay, this is when I'm simplifying. So that's what we're used to doing, right? The grouping symbols first, then exponents, multiplication and division, and then addition and subtraction. When we're canceling everything in order to solve, we actually go the opposite direction. So we can use this as our map for solving also. What that means is when I look at where I am in B, the first thing that I need to cancel is addition and subtraction. Well, this is the thing that's furthest away from the variable, so that's the thing I need to get rid of first. I'll go ahead and erase that. Now, the opposite of negative 1 and 2/10 is plus 1 and 2/10. I cross that off and I get negative x. Let's see, plus 1 and 2/10 equals. Now, I'm going to show you something on this calculator. And again, it's whether it's a TI-84 or the TI-30XS scientific calculator. But notice we have the negative 1.3. If I go and immediately hit my plus sign, it takes the answer that I got previously. That's what this says. And I'm adding the new thing that I'm entering. So plus, whoops. And then when you enter the wrong number, you hit delete, which is a very nice part of these calculators. Okay, so let's see here. I still need to delete again. Come on. Oh, well, we'll start over. Okay, so I'm going to do plus, and then I'll enter the right number this time, 1 and 2/10. There we go. And that is the answer that you get when you combine these guys. It's so handy because anytime you have to rewrite, right, start over and rewrite something, it increases the chance of doing an incorrect keystroke or just, any number of things as we're entering things into the calculators. So that saves you from having to re-enter that last answer. All right, now I still have a negative in front of that x. It may feel like you're done because the x is sitting all by itself, but remember, a negative in front of anything means the same as -1 times that item. So to get rid of the negative, I need to divide by -1. All that does is switches the signs here. It turns it from negative to positive. So x equals 1/10, and that's your final answer. Go ahead and pause the video and try C. I would suggest, and actually I'll put it in the description. I'll put a link to this practice, to the calculator, so that you can practice the keystrokes as you go through and do these. And it's a great resource for any time you're working on your math. All right, so first thing I'm looking for is to see if there's anything I can combine on each side of the equal sign in C, which I can't. So I need to immediately start by moving across the equal sign. So in this case, I'm going to subtract 2. Remember, we're solving, so we're doing opposite order of operations. So I have to get rid of my addition and subtraction first. I subtract 2. And I get -5 4/10 x equals 30 7/10. Okay. X is, or the term with x is by itself now, right? There's something sitting next to it. And once there's an x term and it's the only thing left, then you're ready to do division. It has to look like what you're seeing here in order for us to be able to use division. So that's a good thing. It's kind of a checkpoint, right? If you get familiar with what an equation looks like before you do something, and that's something that happens all the time, taking a moment to kind of, think about that and create that as something that is very recognizable will help you in the long run, especially as these problems get more and more complex. All right, so division, I am dividing by -5 4/10. Divide by -5 4/10. So this cancels, and I get x equals. Now I went ahead and cleared my calculator. I actually didn't have to, but I knew that I didn't need the numbers previously, so I just went ahead and restarted it. So I have 30 7/10 divided by -5 4/10. Now, looking at this, I know, right before I even ran the calculation, I know that that has to be a negative number because it's a positive divided by a negative. That's another thing that if I go in thinking what sign should I have for my answer, then I enter it into the calculator. If it doesn't come out that sign, it means something is incorrect. Maybe you identified what it was going to be incorrectly, which is fine. Or you entered something incorrectly in your calculator. And it would just mean that you would go back and double check. All right, so what did we get? We got -5, and so that was rounded to the 100th. I don't know, just for kicks, I'll go ahead and keep it here instead of going down to the 10th. But for practice, it never hurts, right, to go and round to different places. Now we're moving to to D and E. So go ahead and try these, pause the video, try them. Notice that in D, there's a little bit of simplifying you have to do at the beginning. E, same thing. You have to do some simplifying before you start moving across the equal sign. All right, so for D, looking at the left, I have like terms here because each of these have an X. So I can go ahead and enter those into my calculator. I always say when there's a variable connected to a number, you can run your calculations as though, when you're dealing with addition and subtraction, you can run it as though there isn't a variable. And then at the end, you just add the variable back. So what I mean by that is this is -3 9/10 plus 1 7/10. those x's don't impact how I calculate or the answer that I get. I just have to put that variable next to whatever my answer is before I move to the next step. Okay, so I'm going to do my negative 3 9/10 plus 1 7/10. So I get negative 2 2/10. And here I'm going to add that x equals negative 45 89 hundredths. All right. Now I'm done simplifying, right? On each side, or on each individual side. I don't have any addition or subtraction, right? Where I'm working across the equal side. So I go straight to my division to get the negative 2 2/10 separated from the x. So negative 2 2/10, dividing both sides by that. That goes away because it cancels out to a 1. So I get x equals. Now I notice I have two negatives that I'm dividing. So that means my final answer needs to be positive. All right, now I can't pull down easily that negative 2 2/10 because I'm dividing negative 45 89 hundredths by that. So I'm just going to go ahead and start fresh with my calculation. I have negative 45 89 hundredths divided by negative 2 2/10. Notice that's positive, right? Just like I predicted, because I was dividing two negative numbers. So I get 20 and, let's see. Let's say, I'll round to that. There we go. So 20 86 hundredths, or 20 9/10. So either of those are fine. All right, moving to E, we haven't seen the distributive property in these problems yet. Remember, the distributive property is what you use whenever you have the grouping symbol, in this case parentheses, and what's inside the parentheses can't be combined. And sitting outside the parentheses, you have something that you need to multiply. That means the only thing that you can do is the distributive property for getting rid of those parentheses. So the first thing I'm going to do is multiply through by negative 2 3/10. Now the first calculation is negative 2 3/10 times x. So negative 2 3/10 x. Now, just like before, I identify what sign I should end up with. So I have a negative 2 3/10 times a negative 4 1/10. Well, a negative times a negative is a positive. And then I go ahead and multiply the numbers. So I am leaving out the negatives. You don't have to, but since we already identified what the negatives are, it allows us to just input the positive values into our calculator, which I like because I like to avoid negatives whenever I can. That's the truth of it. All right, so we have 2 3/10 times 4 1/10. And we get 9, let's see here, 9 43 hundredths, and that equals 9 7/10. Okay, now I have nothing else I can combine on each side. So now I need to combine like terms across the equal sign. Well, 9 43 hundredths is a like term with 9 7/10. So I'm going to go ahead and subtract that from both sides. That becomes 0, so it goes away, and I have negative 2 3/10 x equals. All right, so here I'm going to go ahead and do 9 7/10 minus 9 43 hundredths. I get 0 27 hundredths. All right, I'm not quite done, right? I have a term with an x. It's the only thing left. So what operation do you have to do to get the x by itself? Division. It's the only thing that we can do because having something sitting right next to a variable is the same as multiplication. And we have to do the opposite, right, in order to get it canceled on one side and then applied on the other. Okay, so I'm dividing by negative 2 3/10. Divide by negative 2 3/10. That cancels because it becomes a 1. And we have x equals, okay, so I already have the 27 hundredths on my calculator. So I'm just going to go ahead and enter my divided by negative 2 3/10. Ooh, this may be the uglier or the ugliest number that we've dealt with. Not that we're competing, but it seems pretty ugly. All right, so I'm going to do 117 thousandths. There we go. Whew, naming conventions on decimals. All right. Now I could leave it here because again, it doesn't specify. The more places that I have, the more accurate the answer. Again, I'll just go ahead and leave this. I did have to round, right? Because on the calculator, it was negative, which I did include here, yay. And if we look here, it's a positive divided by a negative, right? So we knew it had to be negative. Anyway, I took it up to here. That 3 meant that the 7 stayed the same. So I did actually round here, right? It just didn't change the value for 7 because this number, right, the 3 was not 5 or greater. So this is our final answer. And I'll make it a little more accurate by making that my approximate sign.